Hey STAT students, and welcome to Unit 6. We're starting off with the normal distribution. These first two little sections are just introductory and really they're baby steps to what we're going to be learning. Some important things we're going to learn today is how to use our calculator, things like that, okay? So every once in a while I'll be pausing, writing some notes up, and then you can also pause and write those same notes up too. So today we're going to be talking about the characteristics of the standard curve, or actually I'm going to even take it a step further and add the word normal in there. And we'll be talking down at the bottom about what the difference between a standard curve is and a standard normal curve. Okay, so let's pause for a second and get some facts down. Okay, so let's take a look. A normal curve is any curve that has an approximate bell shape, it's centered at its mean, and it follows roughly that empirical rule. Remember that we learned last unit? Okay, a standard normal curve is that same curve, but it's standardized where the mean is equal to 0 and the standard deviation is equal to 1. We can standardize any data set to help us compare more easily. Here's some characteristics of a standard curve and the standard normal curve. Okay, area under the curve is 100%, so everything underneath this curve is 100%. Area under the curve is a percent and it's expressed as a probability. So I have a z-score, if it's a standard normal curve, that cuts off a part of the curve, and everything underneath that curve is area or probability. And remember, a z-score is a value or a vertical line on the curve, like so, indicating how many standard deviations an observation is from the mean. Okay, so this unit, we're going to be working with standard normal curves and normal curves. Standard normal meaning centered at 0 and 1. Normal meaning centered at a mean and standard deviation according to that data set. And we're going to need to use our calculator to find out the z-score. And we're going to use our calculator also to find out a particular area under the curve given a certain z-score or boundary point. So here's things that you need to know as far as your calculator goes. How do you find your the z-score or boundary of an area under the curve? On your calculator, maybe you have it in front of you and you look and check this out. You hit second, distribution, the button says dister, and we're going to hit option 3, which is inverse norm. If you have a yellow calculator, it populates the fields for you, and it's percent to the left, I believe, for those yellow calculators, and then you insert the mean and the standard deviation. If you have an older calculator like I do, you need to enter these values separated by commas. Okay, find the probability or area under the curve. How do I do that on my calculator? I'm going to use that function, second, distribution. Option number 2 is normal CDF. And this is how I find the area under the curve. So one of them, let's just be clear, this function gives me the z-score that is a boundary line to an area. This function gives me the area. So they're different, although very similar. Here the input is the lower bound, the upper bound, the mean, and the standard deviation. If you have one of the calculators that the school gave you, there's a spot to put all of this. If your calculator is older, then you need to input these values in this way, separated by commas. Okay, one thing to realize though is that your calculator, most of them, is smart, but it's only so smart, and your calculator only reads area to the left. So for instance, up here on this little example I gave you, my calculator from this z-score point will only read area to the left. So if I wanted to know this area on the upper tail, I would have to subtract from 1 since 100% of the data lies underneath the curve. I would have to do some subtraction there because the calculator just, some of them are smart enough, not all of them. So if you want area to the right, you need to subtract. All right, so since we said above that area under the curve is probability and will be expressed as a percent or a probability, we're going to be writing a lot of probability statements. So like this, the probability of X being less than a number, or, the probability of X being greater than a number, whatever. One thing that we need to notice is that if we use less than or equal to or greater than or equal to, this does not matter because that equal to sign represents a vertical line at the exact point we're looking at, less than or equal to, and a vertical line has no area. So the notation does not matter. We will not get stuck on notation. So a single point or like a vertical line has no area. So the notation does not matter. Some people get really stuck up on it. It does not matter. In your calculator, it will be the same. That including that particular value will not add or subtract any area. Why do we use z-scores and the normal curve? Okay, well, there's a little difference here. So we're going to write down the difference. There is a difference between a normal curve and a standard normal curve. Okay, so a normal curve is any distribution that, is approximately bell-shaped. Oh my gosh, I'm struggling to write. Centered at the mean. And approximately follows that empirical rule. Okay. Normal curves are awesome because then we can use them to approximate, we can find percentages, we can look at data, we can make assumptions, things like that. A standard normal curve is when we standardize any data set and we force it to always be centered at 0. The mean is 0, and to always have a standard deviation of 1. Then, where up here, observations are individual data points, specific. On the standard normal curve, observations are z-scores. So units don't matter, things like that don't matter. This is really helpful because we can compare data with different circumstances. Okay, so normal curve, we've already dealt with this with the empirical rule. We're kind of just taking it further. And the standard normal curve is always centered at 0 and 1. And those observations are z-scores. Let's go to some examples on the back. All right, you guys, let's do some examples. Make sure you have your calculator. We're going to learn how to use the normal curve and the standard normal and see the difference. So IQ has a mean of 100 and standard deviation of 15 and follows the normal curve. This is super important. We need to know that what we're dealing with is normal, otherwise these rules do not apply. What is the probability that a random person has an IQ score below 70? All right, so I'm going to go ahead and define my variable that I'll be using, which is X, as an IQ score. And over here, I'm looking at the probability of an IQ score being less than 70. So let's draw a little picture. I've got a normal curve centered at 100 with a standard deviation of 15, and I want to know the probability of having an IQ score less than 70. So let's say 70 is here. I want to know the probability of being less. So I'm trying to find this area under the curve. In order to do that, I'm going to use the function that we learned about earlier on our calculator, normal CDF. I'm going to enter the lower bound. The lower bound value is some large negative number. Whatever you want it to be, you can make it like, I don't know, I usually do like 10,000 or something. The upper bound is all the way up to 70. The mean is 100, standard deviation is 15. And I will put this in my calculator and you should get out the number 0.0228. So what that means is there is a 2.28% chance of observing an IQ score less than 70. So what does this problem look like on the standard normal curve, okay? And there are some instances where you can use a normal curve. Other times you have to use a standard normal curve because if you want to compare two things that seem not comparable, standardizing can help us do that, okay? Also, sometimes you'll be given certain information where you have to work backwards, and the standard normal curve is the only way to go. So let's see what that means. Okay, so on the standard normal curve, recall, we're centered at 0 with a standard deviation of 1. And on this curve, all points are z-scores, not data points. So over here, 70 is an actual data point. Over here, I'm going to find the z-score corresponding to 70. So remember our z-score formula. It's x, which is 70 minus mu, 100, over 15, standard deviation. That's -2. So over here, I'm looking at the probability of a z-score being less than -2. So notice this is like almost exactly the same problem. Just one is set up on a curve in the context of this problem, and one is set up in the context of a standardized curve, okay? So I can use the normal CDF function. The lower bound is something large and negative, okay? Still like -10,000 or something. Upper bound is -2. Mean is 0. Standard deviation is 1. And you should see we get off the same thing, 0.0228. All right, let's do the next one. What is the probability that a random person has an IQ score above 105? All right, let's look at it on the normal curve. So on the normal curve, I'm looking at centered at 100, standard deviation of 15. 105 is above the mean, so I'm just going to wing it, like here, let's say it's here, and I want to know the probability of being above. So what's the probability of an observation greater than 105? Let's put in our calculator, normal CDF. The lower bound this time is going to be 105. The upper bound, you can see, is trailing off, so we're going to put some large positive number, like 10,000 positive. Mean 100, standard deviation 15, and you should get out 0.869. So there's an 86.9% chance of an IQ score above 105. Let's look at the corresponding standard normal curve, centered at 0, standard deviation of 1. I got to get a z-score here. Z equals 105 minus 100 over 15, and we get out 0.33. So this lies 0.33 standard deviations above the mean. So here I want to know the probability of a z-score larger than 0.33. Normal CDF, the lower bound is 0.33, the upper bound is something big, 10,000. Mean 0, standard deviation 1, and you'll notice I get out the same, 0.869. So 2 ways to express one problem, one normal, one standard normal. You need to know both. What is the probability that a random person has an IQ score between 80 and 110? All right, so let's sketch this. I don't like that. I'm redoing it. Okay, so I've got a mean of 100, a standard deviation of 15, and I want to know the probability of being between 80 and 110. So I want this area in between. Probability of 80 being less than, or greater than, x being greater than 80 but less than 110. Now in the normal CDF, I plug in the lower bound is 80, upper bound 110, mean 100, standard deviation 15, and I should get out 0.656. So there's a 65.6% chance of observing an IQ score between 80 and 110. All right, let's go to the standard normal curve now. Centered at 0 with standard deviation of 1. I gotta find the z-score for the 80. So 80 minus 100 over 15 is negative 1.33. And the other one is z equals 110 minus 100 over 15 is 0.67. And I gotta find the area between those. So over here, I'm looking at the probability of a z-score that is greater, oopsies, not x, z. It is greater than negative 0.133, but less than 0.67. So normal CDF, negative 1.33, upper bound 0.67, mean 0, standard deviation 1. And you'll see I get out 0.656. It's the same every single time. This question is different because notice up here it's asking about probabilities. Down here it's telling me I have a 70% of people below what score. So this is using the other function because now I want to find that point, that value that marks off 70%. So let's draw our normal curve. Oops, these are getting really bad. Got a mean of 100, a standard deviation of 15. 70% of people have an IQ score above what? So that means 70% above. So I don't know what this value is, but I know 70% are above that score. Now remember when in our notes I told you that most of the time your calculator, most of our calculators can only read area to the left. So if 70% is on the right, then that means 30% is over here on the left. In order to get this vertical value, you have to list the area to the left. Your calculator is not smart enough to read the area to the right. So we're going to use that function, inverse norm. The area to the left of the vertical value I want is 30%. The mean is 100. The standard deviation is 15. And I will get out 107.87. So 70% of people have an IQ score greater than 107.87. All right, now it's actually a little bit easier to use inverse norm with the standard normal curve. So I've got the standard normal curve here, centered at 0 and 1. And I want to know now the z-score that tells me the upper 70%. But remember, your calculator only reads left. So if 70% is above the value I want, then that means 30% is below the value that I want. So I want to know the z-score now for that. So inverse norm, 0.3, 0, and 1. And I'm going to get out 107.87. Exactly the same. So we're actually going to stop right there. And make sure you read your assignment guide, see what you've got coming up, and I will see you guys tomorrow. You've got homework in your homework packet, and we will go over it tomorrow. Bye.